Okay, so we're basically combining three things we've already learned this year into one activity or one task that we want to do, okay? What does the word polygon mean? What does it mean? Well, three or more, absolutely. It's a closed shape that has three or more sides. So polygons include triangles, quadrilaterals, pentagon, hexagon, heptagon, octagon, nonagon, decagon. All shapes that have multiple sides, okay? So those shapes with multiple sides, what we're going to do is we are plotting those or graphing them on a coordinate plane, okay? So if we look at this, we got to review a little bit because we have our coordinate figures. When we look at this, we got to remember that they come in order X and Y, okay? And our X coordinate will tell us if we are going left to right, and Y tells us if we are going up or down, all right? So let's look at this. We're going to go ahead and we're going to graph the first shape. It's a parallelogram. And then after that, we are going to find the area of it, okay? So if we look at this first one, we've got negative 8, 8. So we're going to go which direction for negative 8? To the left. Absolutely. So 1, 2, 3, 4, 5, 6, 7, 8. And then positive 8 tells me I'm going to go up. And I go 1, 2, 3, 4, 5, 6, 7, 8. So that's where we put our first dot, our first point. Okay? Our second point is positive 5, positive 8. So we're going to go over 5, 1, 2, 3, 4, 5, and then up to 8. Okay? Then we have positive 7, so we go over 7, 1, 2, 3, 4, 5, 6, 7, and down 4. 1, 2, 3, 4. That negative 4 just tells me that it is a negative coordinate, not positive. And then the last one we go back negative 6, so 1, 2, 3, 4, 5, 6, and then down negative 4, 1, 2, 3, 4. Okay, at this point, it is very important that we go ahead and use some kind of straight edge. This one got left on the floor. I have a couple of these back here on the table you may borrow. Make sure if you borrow one that they do end up back on my table before you leave. You can use the side of your paper, side of a book, whatever, as long as you've got some kind of straight edge. But we want to go ahead and connect our dots. So this is what we're doing. We are making our shape.
Can I make it a happy face, Will?
Okay.
Can I make it a happy face?
All right. So once you have your shape drawn, like it said, it is a parallelogram. Okay. What measurements do we need to find the area of our parallelogram? Yep. The base and the height. Okay? So base times height is our formula for parallelogram. So we're going to use this one right here as our base. Two different ways we can do this. Okay? I can simply go and count. Remember we talked about old froggy hops. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the length of my base would be 13. Is there another way I could do this without having to count my units?
Yes.
What can I do?
You can add your...
No, I agree. Keep going. No, I totally agree with what you're saying.
I totally forgot what I was...
Your coordinates. Yeah, you can add your coordinates. If we look at this point is at negative what? Negative 6. Okay? And this point is at positive 7. Positive 7. So negative 6 to 0 is how many spaces? 6. And 0 to 7 is how many spaces? 7. So 6 plus 7 is 13, which is our measurement for our base. You were completely right. Go ahead quickly. Okay, so the next thing we're going to do is measure our height. Can I use one of those slanted lines? No, it's got to be perpendicular to my base. So here's the deal. Any of these straight lines that connect this base with my top could work. I could use my axis. I'm going to come right in here and just go ahead and draw me a little height line just because I want to see it. And I'm going to do the dotted line like we had in all of our drawings last week. So this would be my height, okay? And again, it makes a right angle with your base. And on a parallelogram, it'll make a right angle with both. It's 12. Okay, so we could count it, but we could also say this is at 8, and this is at negative 4. 8 to 0 is 8. 0 to negative 4 is 4. So that'd be 12. So to find our area, we're going to do 13 times 12. What is it? 156. And that is units squared. Okay? So again, what we did, we plotted our points, we drew our shape, we counted to find the distance of our sides, and then we just found the area. Okay? Let's look at a trapezoid. Okay? Again, first thing we're going to do is plot our points. So let's walk through those together. So we've got negative 6. 1, 2, 3, 4, 5, 6, and up to 9. Okay, I'm going to zoom in a little bit so you can see this closely. I think that's as close as I can go. Yeah. Let's see, our next coordinate is positive 1, positive 10. And then we have positive 1, negative 2. So we go over 1 and down 2. And then we have negative 6 and negative 7. So 1, 2, 3, 4, 5, 6, 7. Okay? At first glance, it may look like we're actually tracing another parallelogram. But remember, definition of a parallelogram is that you have two sets of parallel lines. These two lines right here are not parallel. If we were to continue them on, they would eventually run into each other. So those are not parallel to each other. However, definition of a trapezoid is that we have one set of parallel lines. Oops, I'm sorry, that got a little crooked. Okay? And these two are parallel. Now, biggest thing I saw last week was the trouble in figuring out what our base is and what our height is on a trapezoid. So if you look carefully, okay, I want you to think, I'm going to draw it over here. Think about a train track, okay? Those are two parallel lines. These are your bases. Your bases are always parallel. They're going to be like the train tracks. The cross ties, have you ever, and don't do this because it is dangerous, but if you ever walked along the train track and you see the little wooden cross ties that are touching both of the ties or touching both the rails, these are cross ties. Those lines right there, those will represent your height. So even though it's this direction and we typically think height's going to be tall, I could turn this trapezoid any way I want. This is a base and this is a base because those are my two parallel lines. My height is going to be any line that comes in here and connects my two bases. All right? So your height will always be the line that connects your two bases. And it can be any line here. It could have been my axis. I could have just left it like that. So the biggest thing is, don't forget, your bases are parallel and your height will always connect your two bases. Okay? So we've got our lovely formula for a trapezoid, which is height times base 1 plus base 2, all of that divided by 2. So we got to measure our height on this one. Okay, so we're going to come up here and it is 1, 2, 3, 4, 5, 6, 7. Do we agree? Yes. Awesome. So we got 7 times, so we've got to figure out our bases. So if we look at this one came all the way up to, what was it? A 9, right? So we've got 9 and we've got negative 7, so 16? 16. I agree. And then this one was at 10, and this was at -2, so this one would be 12. So 16 plus 12. That is a lot easier than actually having to count them, isn't it? You could count them if you like. You can go through and count them. Okay, so the first thing we're going to do is add. What's 16 plus 12? 28. Okay. What's 7 times 28? 196. That's still got to be divided by 2. So our final answer would be 98. Awesome. You guys are on the ball. And that is always, remember, if it doesn't tell us what it is, it's units squared. 98 units squared. So, it's kind of like, years ago we learned how to ride our bike. We already know how to chew gum. So now we're going to be riding bike and chewing gum at the same time.
I don't know if I want to do that.
Okay. All right, back to me. Here we go. 3, 2, 1. Thank you. Okay, let's look at a triangle. This time we only have 3 to graph. Now, for our sake, remember back when we did distance on a coordinate plane and I was telling you we'll only find distance on a straight line? I need to change one of these so it doesn't mess us up. So change that -7 to a -8. Okay? Otherwise, we won't be able to find the distance of that line. All right? So here we go. We're going to graph -8. So I go all the way back. That's 10, 9, 8, and up to 10. All right. Then we've got +4. 1, 2, 3, 4. And up. Oh, I just messed up. Okay, so there's 10. 1, 2, 3, 4. Right there. Okay. And then we have -8, which is right here, -6. Wait, no, +6. Almost messed up. 1, 2, 3, 4, 5, 6. This is a 10 grid, so there's 10 in each section. So that's why I came up here and counted backwards, because I knew it was closer to 10. Okay, I'm going to connect my dots. What type of triangle is this making? Acute. Very good. I do agree. Somebody said acute isosceles. Yes, acute isosceles. Why is it isosceles?
Because two of the sides are the same length.
Two of the sides are the same length. Remember, so you can define triangles based on their sides and their angles. So based on angles, it's acute. Based on sides, it's isosceles. So you would call it acute isosceles.
Shouldn't it be a right isosceles?
Yeah, you can have a right isosceles, but because these two can be the same. Yeah, and then your hypotenuse would be different. Okay, here we go. Let's look at our base. Because remember, for a triangle, we need base times height divided by 2. So what's the measurement of my base? 1, 2, 3, 4. Okay? Now, I can't use either of my slanted lines for my height, so I got to come right at the middle. Because remember, I want it perpendicular to my base. And I'm going to use this line that comes right up the middle. Now, here's the tricky thing. If you want to count yours, it's okay. But you got to come all the way out to that dot. I had so many people today wanting to stop right here. But your distance comes all the way out here to that dot. But if I look at this one is at +4. And this is -8. So that would be 12. Because we got 8 plus 4. So my height is 12. And then all that divided by 2. So what is 4 times 12?
48.
Divided by 2, which will give me 24. So our area is 24 units squared. Okay? You guys did a great job, actually. Let me pause this real quick.